In the first of this two-part series, we'll work with a React app that was built using the Create React App toolchain, and we'll start working towards turning it into an isomorphic application that is rendered on the server. In this first part, we'll set up our project and dependencies, and we'll build a Node.js server that will serve the rendered app as well as the client-side React application. The purpose of this exercise is to give you a practical glimpse into server-side rendering for React apps. This video assumes familiarity with Node.js and building basic apps using the Express framework. Let's begin. In the previous video, we took a conceptual look at server-side rendering for React. Let's now work through a proof of concept case where we will attempt to convert an existing React app that was built using the Create React App toolchain into a server-side rendered app. We will use Webpack and Babel to build a custom toolchain that will compile our React app and a Node.js based server that will serve both the server-side rendered and the client-side rendered version of our React application. Begin by downloading and extracting the project archive from the link given on the screen. Then head into the Start folder where you will see two folders, namely API and CRA to-dos. The API folder contains a simple API server set up using the JSON server package, which lets you spin up APIs using JSON file databases. This will serve as our backend. So first up, head into this folder and run npm install to install all dependencies. The CRA to-dos folder, on the other hand, contains our demo application built using the Create React App toolchain. So go into this folder and run npm install here to install all dependencies. Our demo API server uses this JSON file as its database. Our to-dos app has 6 tasks at the moment, and once this server is up, we'll get an endpoint that will allow us to add, update, and remove these tasks easily using HTTP requests. So go inside the API folder and run npm start to bring up the API server and keep it running in the background. Our API endpoint is available on port 8080 in this case. Next, head inside the CRA to-dos folder and run npm start, just how you would in a standard Create React app setup. This will bring up our demo to-dos app built using function components and hooks. I can mark tasks as completed, delete tasks, and even add new ones, and all this data persists in our JSON database. The app itself is quite straightforward. To allow our app to interact with the API, we have helper service functions that use the fetch API to place get, patch, and delete requests to our API server to fetch, update, and delete tasks respectively. The app itself features a to-do state array which holds the tasks once fetched from the API. This is then used to render instances of the list item component which displays the task and offers the action buttons to mark the task as done and to delete the task. Now, even though the app has rendered in the browser, a quick peek inside the source HTML reveals no actual content except a root div where the React app is mounted and script tags to bring the app bundles in for execution. A server-side rendered version would instead offer HTML for all the UI elements that you see right now, including tasks, buttons, etc. Since this setup cannot be amended to make it server-side rendering compatible, we'll create a new setup and toolchain. So let's terminate the dev server. We'll then head back to the start folder and I'll create a new folder here called SSR, which is where we'll build our toolchain and a server. I'll run npm init to set up a package.json file first. Then I'll create a folder called src, which will house our Node.js server, which will serve our content. For the React app, we'll create a folder named app inside the src folder. Now, what I'll do first is copy the contents of the src folder from my CRA to-dos folder and we'll paste it in the app folder here. We have thus copied our React code, including the style sheet, into the app folder here so that we can compile it using Webpack for both the client as well as the server rendered edition. Let's first build a Node.js server using the Express framework, which will serve our React app code as a JavaScript app and the server rendered version. So let's first install React, React DOM, Express, and Axios as dependencies. We need React and React DOM to render our React app on the server, while Express will be used to create a server application easily. We will also use Axios to load initial data from the API server so that the server rendered edition does contain actual tasks. Next, we need to install development dependencies. These are packages that will be used to build our toolchain but are not part of the final deployment package. I'm going to install all of them in one shot, so let me walk you through the packages. We'll use npm i-d to ensure that all of the following packages are registered as development dependencies and not core dependencies in the package.json file. First up, we have the Babel core package, which brings in the Babel compiler, which is required to compile ES6 and React code. Next, we have the preset env package from Babel. This is known as a preset, and it allows Babel to compile ES6 code such as import statements and arrow functions. Similarly, the preset React package allows Babel to compile React and JSX code. We are then going to need a package called Babel Loader, which Webpack uses to take help of Babel to compile all code using modern JavaScript features and React. Likewise, the CSS loader is used by Webpack to process CSS. We also need the ignore loader to selectively prevent processing of certain files. The purpose of this will be apparent once we start building our Webpack-based toolchain. I will also bring a Webpack plugin named Mini CSS Extract plugin. This will be used to compile and write a style sheet in our final production build folder. Then we'll bring Webpack itself along with the Webpack CLI utility. We are also going to need the Webpack merge package, which will allow us to write modular Webpack configurations easily. And finally, we need the Webpack node externals package to ensure Webpack doesn't end up processing contents of the node_modules folder, which houses all our dependencies. These are a lot of development dependencies, but each has a defined purpose in the project. Okay, our next task is to build a Node.js Express application that serves our React app as well as renders it on the server. In the src folder, I'll begin by creating a file named server.js. I'll begin by importing Express, React, and the very important render2string function from the React DOM/server library. The render2string is a special function that renders React components to HTML markups, and this is the basis of server-side rendering. We'll also import Axios for later use, and finally we'll bring in the app component from the app folder. This is the root of our project. Note, we are not importing the index.js file that sits in the root of the app folder, but the app component, which is the topmost component that ultimately renders on the page. Next, I'll set a constant called API server, which points to the endpoint URL that will be used to fetch to-dos on the server so that we can render them in our server-side version of the React app. I'll thus set an environment variable named API_server, which can be used in deployment environments to set the endpoint URL of your API server. In its absence, such as in the case of development, we'll switch to our API server endpoint on port 8080. I'll also configure a port variable in the same way for our Node.js server. Typically, we'll get our server to run on port 3000 unless configured by the deployment environment. I'll then instantiate an Express app which allows us to handle requests and responses and enables us to easily declare routes. Now, for the client-side edition, once Webpack compiles our React app to be delivered as a bundle to the browser, it will place JavaScript files in a folder called JS inside the build folder, which it will create. We thus want to serve that folder so that the app bundle script can be loaded in as an asset. Likewise, our style sheet will be stored in the CSS folder under build, and we want to serve this as a static asset too. These two statements allow Express to offer these folders as static assets so that the server rendered web page can bring in the client-side React app code and the style sheet easily. Now, a web server allows you to create route handlers. So let's create a route handler for the root route like so. The callback function here is invoked if the user requests the root route and incoming data is brought using the request, while you can send back a response using the response stream. Now, getting a rendered HTML markup for your React app or a component is as simple as invoking the render2string function on the component. Once I have this, I can send this back as a response. But we won't just send the HTML markup for the app. We need to send a fully formed HTML page with the root div where our React app is usually rendered. In our case, the root div won't be empty but will contain a rendered version of the app. Additionally, we need script and link tags to bring in the style sheet and the app bundle for the client-side React app. So I'll create a function called html_template which will accept this rendered app markup and return a fully formed HTML page with the app included in. Here we have a basic HTML page. In this page, we'll add a div with the ID root, a script tag that brings a bundle.js file in, which represents our React app, and a style sheet for the application. I'll now copy this HTML into a string literal and we'll simply insert the rendered app here. Now using this function, we'll compose our response and send it back to the user with the res.send function. Finally, we want our app to listen to port 3000. With our server now ready, we are ready to build our toolchain using Webpack and Babel. The render2string function, while rendering the React component as an HTML markup, also adds React-specific DOM attributes such as the React root data attribute, which is required by React on the client to acquire and turn the static markup to an interactive and dynamic client-side app. Now, if you're building a server that uses streams, you can use the render2node_stream function, which returns a readable stream for the HTML content. You can also use React to build static content. In this case, instead of using render2string, we can use the render2static markup function. In this case, React does not add internal DOM attributes such as the React root data attribute. We have used render2string in our project. We'll implement the ever important hydrate function in the next video as we build our toolchain configuration for Webpack.